See question. We have been given these two statements, and from them we need to determine which of the above statements is or are true. So let us have a look at the first one. It is saying that if L1 and L2 is regular, then both L1 and L2 means individually both L1 and L2 languages must be regular as well. That's what it's trying to say, which means we have two languages L1 and L2 such that their union is regular. So does that implies that both L1 will be regular and L2 will be regular? So let us take some examples and try to understand this. Let us have L1 to be something as A star. It is definitely regular. And then in this case, if we take L2 as something where A raised to P, where P is a prime number. So now this L2 is definitely not regular. L1 is regular. So their union L1 union L2 will definitely still be resulting into A star, and that is regular. So this was one of the contradictory examples where we had only L1 as regular, L2 was not regular, but still their union turned out to be regular. Or in the same way we can say that let us take L1 to simply be sigma star. And now whatever we take L2 as, if we restrict the alphabets to just A and B or whatever, then whatever combinations you apply for their in language L2, then still their union is always going to be regular because this L1 has accommodated everything. So again, this is an example where only one of the languages is regular, but their union is also regular except that L2 is not. So this first statement definitely looks false. And now going for the second one, the class of regular languages is closed under infinite union. Again, this is a well-known property of regular languages that they do not satisfy infinite union. And the standard example that we give for such cases is that you can have a language such that on the alphabet set A and B you will have A, B, then A, B, B. You are taking union of all of these languages independently. Then triple A, triple B, and so on. So when we take union of all of these combined together, then at the end that results into this particular language, A raised to N, B raised to N, and some limitation on greater than 0 or 1, something like that. So now all of these languages, when taken independently, these are the strings basically for that language, and hence they are taken to be regular. If we have just a finite string having some, let us say A raised to 9 and B raised to 9, then this is a finite language. There is only one single string in it, so it will definitely be regular. And whatever the value we increase, A raised to K and B raised to K, as long as we keep it to be a finite language, it is going to be regular. And when we take union of all of these regular finite languages, then it results into this particular language, which we very well know is context free and not regular. So when we go on to take infinite union of many different regular languages, then it may be possible that the result is not always regular, and hence it will be saying that it is the regular language class is not closed under infinite union, which means again this statement 2 is also incorrect. So we'll be going with option 4, that neither of the two statements is true.